Good evening, gentlemen. I am Asita Jayarathna, a member of the Mechanical Engineering Sectional Committee of the IESL. It's my privilege to welcome Professor Jay Sarath Gunasekera and all of you on behalf of the Mechanical Engineering Sectional Committee. This is our 8th public lecture we could have organized in this year. Today we have another great opportunity to listen to Professor Jay Gunasekera on his presentation of global view of engineering education. Professor Jay Sarath Gunasekera had been the chair of the Department of Mechanical Engineering at Ohio University from year 1991 to 2006. He is an internationally recognized researcher in his area of metal forming and manufacturing. He has undertaken research and consulting projects for large number of foreign companies including GE, Pratt Whitney, GM and the USAF. Professor Gunasekera has published over 150 technical publications in different journals and conferences. He was awarded the higher doctorate degree D.Sc by the University of London in 1991 for his research and publications contribution in the field of manufacturing engineering. We sincerely appreciate accepting our invitation, Professor Jay Gunasekera, and we sincerely welcome all of you for this event. So let me invite our honorable presenter today, Professor Jay Gunasekera, to deliver his lecture. Thank you. Over to you, sir.
It's not enough.
Very sort of
informal. I want to thank the Institute of Engineers for inviting me. I think it's a great honor for me to be here back again. I was here probably in 1974 or 75. Gave a speech on production engineering. I don't know whether the DLO might have been there, I can't remember. But I can remember, I don't know whether you knew Mr. Rampala. He was living that time and he was in the backwards or somewhere in the thing, and I gave a presentation on the need for production engineering. That time we call it manufacturing engineering now, and I gave a presentation and gave a paper that time. Of course, I'm new to that, and he said that. Of course, he said the right thing. He said this is Godata magic. So I should, because I'm a newcomer to manufacturing, even though I had a PhD from there, I haven't had much experience. So I'm going to talk about that a little bit, industry experience. And he was absolutely right about that. But also, I'm a Godaya because I came from Ratnapura, it's a village. So I'm actually a village boy, yeah. Thank you for coming, everybody, and I appreciate your coming here. I'm going to talk about engineering education in broadly and view which I have experienced. So it's coming from my experience. Can you hear? Everybody can hear properly, right? I don't have to get closer, right? Very good, thank you. You are welcome to ask any questions, even in the middle. If you want to raise your hand, that's fine. That's my way of telling the students, you're not students, but if you want to interrupt halfway through to clarify something, that's fine. I'm giving you a background a little bit to say where I'm coming from. Some of you may not know me, so I have got these degrees here. I started the Department of Production Engineering in Peradeniya, long time ago. And then Dr. Sanatranathan, some of you might know, took over that after 2 years. And he was really a practical engineer, like Para Jai Singh here. Some of you are very practical engineers, and I think Sri Lanka needs people like that. So we are going to talk about that a little bit here, what we are lacking in some of our universities. In my experience, again, it's my opinion, and you don't have to take whatever I say. You can filter and take the best of the presentation here. I have done some consulting, fortunately, at IDB. When I was a lecturer, I traveled every Friday from Peradeniya to Colombo to Katubad to work at the IDB. All the time I was there 5 years. I think I was coming 4 years. I learned a lot about small industries. Not only that, I gave up set up the industrial estate as early as 1977, 76, 77 time. We started with, fortunately, my father-in-law was the district minister one time there, so he was able to get land and all that. We got land from the government. Started with 5 industries. Now there are more than 150 industries in Horana, giving jobs to a lot of people. Started with rubber gloves and rubber slippers and various rubber stuff. So I got the idea from the IDB because they were helping small industry. So you can see that. And also I was a board director of the Steel Corporation. I was telling about that because I have no connection with UNP or ISLFP. You know, I have worked for both, as you can see. I was a lecturer, senior lecturer at Monash from Sri Lanka. I worked here for 5 years in Peradeniya. And then I was very fortunate to get a sabbatical at Wright Patterson. I always wanted to go to US, mechanical engineer. The best place is US. So I thought, why should I, wait all the time in Australia? Might as well go there. My wife, the kids didn't like it. They want to be in Australia because Australia is a beautiful place and nice country. Well, why do you want to change? So I came there, and then I did so much good work for Wright Patterson. Every Sri Lankan student, or all of you guys, are much brighter than an equivalent American student. Much higher level here. One reason is obviously Katubad, the Moratu, or Ruhuna, everywhere, and Peradeniya get the best cream of the students from Sri Lanka. In the US, anybody can go to the university. So the average quality of the incoming students are much higher in Sri Lanka than in the US. That doesn't mean the brightest, there are brightest there, of course, probably brighter than here. But the average I'm talking about, because you're averaging everybody, anybody can go to university there. But I think they produce very practical engineers that we can learn from the US and other countries, Australia, UK, Germany, or wherever. We may be lacking in that. We may be good in academics, but we are lacking other things like design, for example, design stuff. I'm going to talk about design projects in a little bit here. I did design this for Lockheed Georgia that time, and they were so happy to have me. They said, "You're not going to go back to Australia. You're going to stay here. Work for us." I think US is a place where if you are a good person, they don't care about the color, race, religion. They want to have you. Okay. If you're a good, productive person. So that is a good quality. Which country, Western country, will have a black president? Nobody has, right? Australia, Germany, England. So they don't care about that. They care about whether you can do the job. So I was given a couple of professors' positions, and you can see I also worked at Berkeley for a year. And I have done a lot of consulting projects. See, that experience with the IDB, and that helped me a lot. So I'm telling everybody, even the professors and the lecturers, should get some industry experience. That is the emphasis. We talked about that with Para a lot here. I have done over 50 projects, research projects and consulting projects. Of course, it's easier relatively to get consulting projects in the US because there is a whole bunch of companies that are wanting people like me and others to work. These are some of the stuff I have done. So you can see the variety. I started with aerospace companies like Rolls-Royce, Allison Gas Turbine, GE, which makes turbines, National Science Foundation and all that. So, and then I slowly moved into sorry, is there a disturbance? With car manufacturers and automobiles, stuff like that. As you can see, American Axle and manufacturer. So all my projects, I'm going to tell the lecturers or professors if they are listening, should do projects, always student projects with industry. There must be some connection. There's no point doing a project for nothing. You have to associate that with industry. Okay. So the BS program at ME at Ohio University, which is similar to most accredited programs, there could be some differences. 4 years typically, with co-op with 5 years. Co-oping means you work in industry 1 semester, come back and work in the university for 1 semester. So you interchange between the university and the industry. So it might you do it in the second and the third year. Second, third, fourth years. So the first year is common. You can't do the co-oping. Last year you can't do it. But in between you do the co-oping. You must have A student and B student. Then they interact. So the company can give the same table and the chair to the other guy coming in the next semester. So they can interchange. They do the same project. So that helps a lot. They also do humanities and social sciences. This is debatable, of course. That is the style in Canada and the USA, that we also teach humanities and social sciences, at least in the first year, so that you get an understanding, engineers understand what is happening in the politics, or they can do political science if you want as a subject, or social science, some history or geography or anything. There is a requirement in that also. We don't have, there is a requirement of English. Even though they speak English and they write English and they have done their whole life of education in English, they still have to do English in the engineering program also. So that is a must. Then the senior capstone design project, last full year. There are courses, but that is the main thing. So it's hands-on experience. Okay, so I'm going to talk a lot about that. I'm going to skip some of these slides. So we have a BS in energy engineering also, in addition to mechanical engineering. Okay, so there you can get a BS, BSc or Bachelor of Science in Engineering, Energy Engineering, and MSc in both of them and so on. A lot of projects, many projects for disabled people. We do that for African people, and students go there and work with them, install solar projects. I'm going to show you a few of that. That gives a lot of experience for the students. This is the main thing we do. Capstone design, that is your final design, as a mechanical engineer. You are going to do a design project and you are going to use all the material you learned in the previous 3 years if you are doing a 4-year degree. Project that will make a difference in life of someone. That is key here. You have to make a difference. We are here, engineers are here to help the society, help people, help the country, help society, whoever. So you don't do anything without that objective. You have to do that, in my opinion. So all our projects are tied to that. Okay, help a company, help underprivileged people in other countries or whatever, or do solar energy or do wind energy, which will save the environment, that kind of thing. Effective teamwork, I highlighted that. Project management and professional skills are very important. So you work as a team. Okay. Capture the voice of the customer into meaningful design specification and criteria. So that's important that the students have to do that with the help of the professor, obviously. Feasible design concept, do a prototype, design, mock-ups, tolerance drawings, manufacturing plan, and manufacture and assemble a working prototype. We don't do that in Sri Lanka. I haven't done that, so I'm equally bad that way as a student here in Sri Lanka. We actually do a design, but we don't make it. So I'm going to show you examples of what we have made in the past. So I have learned after graduating, even though I got a superior education in Peradeniya, I should say that. At Imperial College, of course, I don't want to boast about myself. I did very well in Peradeniya, but even at Imperial College, I didn't have any trouble getting all A's. Okay, so that is what I'm telling you. Even any student coming from here will do very well. In the UK, I think Professor Ranjit Silva can attest to that. He has been in Singapore. Singapore is, of course, very high level too at the high school education. Test mock-up trials, manufacture total cost, and even a user's manual they have to do somewhere here. Yeah, user's manual. So it's a complete thing they are doing, including maintenance, product service information, product support, improve the prototype, so that they are well experienced. When they go to industry, they will be asked to do such similar things, they can do it. Improve the prototype as necessary. Apply design methods, create a low cost transferable design, estimate production cost, complete the documentation, validation of the design, and so on. And even go for external design competition. There are a couple of two examples I'm showing you. One is this senior design drag stay race. This was a couple of years old. I'm not the main person who does design. That is Greg Kramer. I'm going to show his picture and the stuff he has done in the past. I help sometimes with the manufacturing part. I teach design also, by the way, mostly machine design. And then regular dragster. He fired heat engine driven machines in which the entire system, including the heat engine, was designed and built from scratch by the teams, including the heat engine. Okay. And then the externally fired heat engine. Think about that, okay? In the team lineup picture, notice that the 4 steam engines, first 4 places are shown extreme left, and the Stirling engine is shown the extreme right. Yeah, you know, I think Dr. Nalin Valpit is familiar with that Stirling engine stuff. Here, see, here is our front of the building. Here are all the, you can see some of them are steam driven, some of them are Stirling engines, and so on, you know. And they actually build it. We have a workshop, and they can go to the workshop. We have the first year workshop like you do in Monterey and Peradeniya, but they actually build it. They design and build it. Whole year it takes, though. That's fine. They do the design, get the approval from the professor, and build the whole thing. I think that's important because we can do a design. I think I did design when I was a student in Peradeniya, which may not work. I don't know whether it works or not because I haven't tested it. Okay. So powered shopping carts. That is to help people who can't. This is motor powered, either battery powered usually, so that you know they have this team of people building this. They actually build it. See that other pictures of that. Some examples. What? Go back. Cerebral palsy, right? Yeah. Who has a problem with the thing, right? Yeah. Back. Yeah. I think so. Yeah. I'm not a doctor, but I think it is that. Yeah. Somehow they can't walk without the assistance. Yeah. So this is entirely built by them. They might buy parts and so on, but essentially they do the whole thing. They understand the tolerances and things like that. Prosthetic arms, force reducer. Again, I don't want to spend too much time, but you can see the input required is less. There's so many soldiers who have lost their hands and in the war, various wars, unnecessary wars that the US conducts in the Middle East. They come back without a hand, without a leg. So that we try to help them. Firefighting system. Some examples. This is Dr. Kramer. Greg Kramer is the chairman right now in mechanical engineering at Ohio University. I actually hired him. I have hired about half the faculty, the college professors now existing. I was the chairman one time. So this guy was hired from GE. He had worked 5 years at GE. Everybody has worked in industry when I hired. Everybody, at least 5 years minimum, they have worked in industry or associated. This is his house in the rural Ohio. I'm not far away from his house actually. And this is his solar power and the wind. His own house. So he doesn't have to pay any electric bill at all, ever. And he has an electric car too, I think. Yeah. This is a project he did in Ghana. Several projects. He always takes students to Africa, and I have asked him to come to Sri Lanka too. In fact, we are doing a project with Nalin and them, so hopefully he will help us also in that one. So he likes to help developing countries. Go and help. This is the water pump project. This one is very noteworthy because this village, no electricity, middle of nowhere in Africa, far away, no electricity. So what did he do? He put these collectors, solar collectors, and then pump water there is a battery backup, they get electricity, 1 or 2 bulbs in the hut, okay, that's enough. And then they have water, which they have to carry from far away. So they have a tube well or something and a pump attached run by the electricity, and that is a terrific project in my opinion. The students get practical experience, they go to Africa and they live in these huts, you know. They are not used to living in there. Even I probably can't do it, even though I came from Sri Lanka. This is a newest item which came recently. Ohio University among the nation's leading green power users. So we are very much into green power. In fact, in June at IIT, I'm giving a workshop for 1 week on green manufacturing, where we reduce the power usage in manufacturing and also reduce the lubricants, harmful things to earth and all that. We are trying to use, instead of for coal forming, sheet forming, using petroleum-based oils, we might use vegetable oil, that kind of thing, so that it is biodegradable, that kind of thing. So 50% of these are graduate projects I'm going to run through quickly. If you have questions, ask. So this is some of the master's projects and PhD projects we have done. Every project I have done and other professors have done is with industry, some kind of a connection. Okay. Forming process, die design using computer modeling. This is my project actually. Turbocharger impeller, everybody knows what is that, coincident forging. They were only doing steel forgings in the beginning. They are never done. I met the owner at a conference and got friendly with him, and he said, come and help me to do this kind of thing. He has never done turbocharged impellers in his life before. So I started helping him, and I got him a huge contract to do probably millions of impellers. He doesn't machine them because you need a 5x machining. Again, I'm not going to go into detail here. Forging parameters, he has only about two or three presses there. Small company. Solid modeling, very important for the undergraduates, obviously. Various kinds of things that you have to do. One of the things in an impeller is they rotate over 100,000 RPM. I mean, that's a huge speed. If you look at the centrifugal forces at the end of the tip of the impeller, it's going to be large. So they are going to fly out and break. So you need a certain amount of strain. Dr. Ranjit Silva will appreciate that. That the microstructure has to be right. Fine grain, the microstructure, and this design involves a dead metal zone. Dead metal zone is what you get stuck here. If you are a forging guy, you know that. There is a certain aspect ratio of the billet that you need to worry about to install that strain into this billet. So we designed with my students, and I came up with a new idea of a design where you do this with a cone, because the dead metal zone is here. You're going to penetrate that and make a strain on that. Otherwise, it's going to get stuck into the die. This is hot forging, so it won't do it. You can see some of the analysis here. Hopefully you can see that. So that is the first stage of the design. See that there is a red zone here which is high strain. We need at least 0.5. See, this is blue. This is less than 3.3 strain. So this is not dynamic recrystallization. Some of you may not know, but it is needed to refine the grain structure. It works? Yeah. So you can do that. The blue part also became green. And the final stage of the forging is that. This is all simulated, of course, obviously. You can see the strain, that is the advantage of this simulation, is that you can do hundreds of runs, okay, and optimize the die design or the parameters that you want to design. I'm going to go through this quickly. This is the practical stuff. So you're comparing the experiments with the thing. Also, never do finite element modeling and don't do experiments. You have to do an experiment. Okay, somebody has to do it. In this case, the company did it for us. Okay, we can do material testing, but we don't have a big press to do this kind of forging. So this is the first stage of the forging, final stage of the forging. You can see the rise of the forging load. This is the actual after machining. they don't do the machine. Okay, it's a 5-axis machine that comes and machines it. This is the stages of forging here, as you can see here. You can see the simulation and the actual. So the student gets a lot of experience. We also validate. We don't believe the computer. We have to validate it, and we make sure that the validation is 8% error, whatever, 1.3% error. If you get a 0 error, then I will be worried. There's somebody's cooking the data. You know. Yeah, so there should be some error. That's okay, small error. The modeling is not 100%. You get a good idea from that. So you can compare the dimensions, all that. So let me go through that. The microstructure, as you can see, the grain flow, macro. The grain flow can be seen very well. Again, another one, you can see the grain flow here. Some of this will be machined, obviously. So anyway, the conclusion is that we came up with a good design. Ring gear forging, this is for the automobiles and trucks, and again, I'm going to show you the pictures of that. They used to do it in these stages. So start with that billet, original billet, heat it up, bash it one time, another time, third time. Then fourth time you trim it, the flash, and then you machine it. Okay, 5-axis machining again, or gear hopping or something, whatever. In fact, I want to make it that shape, what we call near net shape forging, with the teeth. So I'm proposing that you can make it without the helical bevel, with teeth, with the other smaller gears that you have, not the bevel helical gears, which is much harder to forge with the teeth. Okay, so that is the kind of thing. Again, I'm not going to go with the modeling here. Current forging, reduced forging. If you reduce the forging, it's a huge advantage to the company, because you don't have to material handling. Material handling, even if it's robotic or people handling, it's a lot cheaper, because labor costs are very high and they don't want to handle it. Okay, so we reduce that from 3 stages to 2 stages. We reduce the temperature. That is a lot of reduction. We were over 2000 degrees Fahrenheit, and that will mean reducing the cost of energy in the heating. Now this is my pet project. This is the project I did when I was at the Air Force. Streamlined die extrusion dies. Okay, so I think I'm one of the first guys who did that with the Air Force. 1981 I went to the Air Force. I worked there till about 1982-83, and there was no CAD/CAM at all. Computer design, computer manufacturing was just coming in. There was no AutoCAD, there was no all these Superforge, all this software, even what is that, Pro Engineer, all of that were not there. They came much later. Yeah. So I designed these dies. See, these are the shapes. This was done with a normal computer, very slow computer. That time, this is 1982 stuff. There was no CAD/CAM that time. No commercially available. Yeah. Stream can design all kinds of. Actually, to tell you the truth, the Air Force said you can. I developed the software to a certain extent. They don't want to own. The government doesn't. U.S. government doesn't want to own anything. You take it. You have the rights. If you want to do a company, so I started a company and started selling software. I improved it much more. So I sold it to some of these aerospace, including Airbus. I designed a die for them. Not Airbus, but the people who do the parts for the Airbus, which are in the US. So, some of them at least. Wingspa, I don't think I have a picture for that. Yeah. So I did a lot of projects with these jet engine manufacturing projects in the past. I have worked with the Air Force, Navy, Pratt Whitney. These are the largest, the only three, who are the only 3 commercial jet engine makers: Pratt Whitney, United Technologies, or GE, or Rolls-Royce. There is nobody else who can make those large engines. No. Small engines they can make. There is a lot of other companies. See, sponsor is that. So I have done a lot of sponsors project worth millions of dollars actually. Critical needs of rotating parts, high cycle fatigue. We are as mechanical engineers, we have to worry about that as materials engineers too. High cycle fatigue, rotating parts, reciprocating parts. So we need to worry, Engines run at very high speed. Again, I'm going to run through this quickly. This is the blade, one of the vanes or blades for the jet engine. Project was GE, General Electric, the jet engine. So this is the pinch and roll process. The blades are made like in 20 different ways. You can forge it, you can cast it, you can forge it, you can roll it. You don't think you can roll it, but you can roll it. The rolls have a three-dimensional shape, and they don't rotate all the way. They rotate about 60 degrees. They take the part and do that quickly. I don't think I have a slide for that, but this is the extension of that. Then you trim it at the end. Okay, this is called the platform. This is the shape of the blade. These are the dies. So this company gave me like a $500,000 machine in my lab. It was there for about 3 years. We did all the experiments. My students did the experiments, to tell you the truth. These are the dies. They provided a guy too to help set up the machine, but we ran all the experiments and improved the process a lot. So the advantage here is that there is no machining on the surface of the blade because it's high polish. It's cold roll. Okay. Here is the machine. We put sensors everywhere, as you can see. As engineers, we like to put sensors, right? Sense everything. G set up Ohio University. I was the director of that center for a long time actually. So you can set up the machine with the computer, with a laptop like this. You plug it into the machine and then you can set it up. You can make sure that they are placed well. You can roll. Earlier they used to roll like 10 or 15 to get the right thing by hand, by manually. Now they can do it using the computer. Of course, use the computer, you can measure everything because we put sensors, right? We put sensors, we can know the position of the thing, shuttle position, bottom harbor position, top harbor position, everything, pressures on the hydraulics, so we can measure the force on the thing, everything we can measure the angles, we can measure the shape of the thickness, all kinds of things. Then another project I'm going to rush. How about the timing? Is it okay? Am I doing okay? Yeah. So ring rolling is another pet area of mine. Only way to make a seamless ring, which is a thin wall, like a rocket engine or a jet engine cowling or a shroud, what they call, is ring rolling. There is no other way. If you make it that way and join it, then there is a seam, there is a well there. So if you want to avoid the well, unless you take a huge bulk of material, titanium, or super alloy, which is Inconel or something, and then hog out the middle, which is a waste of time, right? Time and energy and everything, material. Okay, you're going to produce soft. So what you do is you forge a piece, billet, upset it, punch a hole in the middle, put the mandrel through that, and roll it. You can contour these rolls if you want a little bit. The mandrel can be contoured too to the shape you want. So if you look at the 4th and the 7th and 8th stage of a jet engine commercial, they're like a little taper because the compressor is going that way and the engine is going that way. So you have to make that shape of that which carry the vanes. The vanes come from that, right? The blades are rotating inside. See, there is another picture of that. So you start with a smaller diameter and you reduce the thickness of this ring. Okay. They were when I was talking about ring rolling, a lot of people ask, are you doing this? this ring? No. These are large rings. I have worked with a company called Viking in Reno, Nevada, and they make those shuttle casings. And they are about half the size of this room. Okay, so the machine can produce like a 30-foot diameter, 40-foot diameter ring. Continuous. I mean, there is no seam in that, no well line, no anything like that. So they can do this. These are called radial rolling. This is called axial rolling. So you can control the size of that. By the way, my rolling mill is the only mill in any university in the US. No other university in the US has a rolling mill, experimental rolling mill, which is like a desktop model, but it works. The only ring rolling mill in any university in the US. Germany has 2. Aachen University and another university. University of Manchester has one, and that's about it. I don't know, but of course the industry has a lot. They make these large rings. This is the design was done by my student. Completely, all the drawings, everything. Construction was all done by my students. except buying the hydraulics and the motor and various other things. 100% done, everything was done by my students. Okay, we put sensors everywhere, as you can see that, LVDTs, measuring the size of the diameter and various other things, Whole thing was designed and built by students. Not by one student, but, several students at various stages. So you can see the ring starting at a small diameter and expanding to a larger diameter. Now I want to talk about a little bit of student outcomes, ABET accreditation process. Most universities in the US, good universities or accredited universities, are accredited by what is called ABET, Accreditation Board of Engineering and Technology. If you are accredited, it's a good thing, because that means people come every 3 years or 6 years to the university, 3 or 4 people as a team, look at the labs, talk to the professors, interview them 2 or 3 days, interview the students, interview the graduated students, interview the people who employed the students, and make sure the quality is there. They are up to the quality. Okay. So all these criteria are there. I don't want to read all of them. Ability to function as multidisciplinary teams, ability to identify, formulate, solve engineering problems. So there is a lot of list here. Not just math only. You can go to that website and get it if you want to. Engage in lifelong learning. Contemporary issues, you need to know that. Modern engineering tools for engineering practice. This is our program educational objective. So every university has a program, has an educational objective. So you have to prepare the graduates for engineering careers, mechanical technical skills, and so on. So again, I can leave some of this with the IESL or somewhere if you want to read it more. Student outcomes. We have what are called outcomes. We don't measure it by the professor doing a certain syllabus. We need to know what the student has learned. The outcome comes from the student. It doesn't matter that if the professor is teaching the stuff, if the student doesn't get it. Okay, so there is a way ABET does that. Those are called student outcomes. These outcomes are these kind of things. Apply principles of engineering and mathematics, all kinds of stuff. Design and then realize mechanical and thermal systems. Design, conduct experiments, and so on. Okay. These are our design. Design is emphasized here a lot because everything ends up in a design. So you learn math and controls and robotics, everything has to end up in a design at the end, right? You're engineers, you design civil structures, mechanical, chemical, anything, and then be able to manufacture it. Even though somebody else is manufacturing, the design engineer should know some manufacturing. How is it going to be made? Can it be made? Is it cost effective to make it? If the design engineer doesn't know that, then he'll design something which is ridiculous to make, impossible to make, or cost like a fortune to make. Communicate effectively. I think I missed that. Sorry. Demonstrate an ability to communicate effectively. I think I talked to Para and he says that nowadays students here can do that very well. When I was a student, I could not speak in public. In college, in the school, I used to cut class and get sick when I have to present that day, because I was never learned how to speak in public, because my parents did not, coming from the village obviously, I mean, you go in the back, right? You're not allowed to speak. This is, I'm talking about 40, 50 years ago. Okay, so now things have changed, and I'm glad that it has changed, because you guys are able to, some of the students can talk effectively, not only talk but write presentations. All that is very important. Okay, so some of these I'm not going to go through that much because no time. Broad education is important in my opinion, but we don't do it that much in Monterey and Peradeniya, and also maybe in Ruhuna. We believe that there is some economics, management, environmental issues are important also, at least in somewhere. Not the whole course, maybe a couple of courses in that classes, couple of classes or courses, that they should be able to learn on their own. That is important also. Measurable outcomes. Again, I'm not going to read that. We define a target course, so we can check it with a course whether they have satisfied it. If they haven't, then how do you correct it? We have a continuous improvement program. Okay, we get a feedback and then we change the course. We get input from people who are hiring them. We get from the advisory board. We have advisory board who are all from industry. They give us a feedback. So we improve the course every year, every semester. We don't stop, you know. So that is how we improve, and we use. This is the advisory board. They are typically who are graduated from the same university or department, and they have taken jobs and they're managers or whatever engineers, and they come. We have about 15 of them. They come and advise. All of them can't come, so maybe 12 will come or 10 will come, and they also get invited for the design stuff. So they come about 2 or 3 times to the university, help the students, help the professors, do projects and so on. Student advisory board also we have. Okay. So that also we take input from them also. This is another thing I visited last week. I was in Singapore visiting my daughter, who happens to be there for 3 years with the husband who got transferred or got a new job there. So I happened to, I was, Singapore spelled wrong, I'm sorry about that. Yeah. I'm not good at typing, so do that. What they have is 4 pillars. 4 pillars, I just typed this today because I gave one copy to Dr. Nalin Malbit also of this whole brochure. They don't have, this is the brand new university. They don't have traditional ME, CE, chemical engineering, electrical engineering programs. They have these 4 pillars. What is called engineering product development and design, architecture sustainable design, engineering systems and design, information systems technology design and so on. So they use mechanical engineering stuff, but these are the 4 programs they have, pillars they call it. Okay. So I think it's a great idea, I think, because it depends on the need of the country or the society. Also, Singapore has about 3 or 4 other universities who do the traditional stuff. So this is going away from the tradition and going in a different direction. They have a collaboration with MIT in the US to do this. And when I went there were about 10 professors from MIT visiting them. You know, every semester they come and do it. Apparently, they have a US $100 million contract with MIT. I don't think we can do that. Singapore is a rich country, but that's it. I like to start a discussion and ask questions if you have any. You know, I try to rush along. You know. Thank you. Privileged that DLO is here. He's actually one of my gurus, because when I did the second year or third year vacation, he hired me, and then he took me to every site in the country, civil engineering sites. I wasn't sure what I was doing second year, I think. Yeah, he took me in his jeep with a bunch of other guys. Rahim was there, right? What's his name? I forget. Bhupen was there, Bhupen Silva. And who else was there? DLO, I can't remember. You took me. Driver was there, you were in the front seat. I was in the back seat with some others. He took me to every site of what is the company? Ceylon Development, CDE. He was the chief engineer or something that time. And I haven't forgotten that. And I'm so honored that he's here. And then of course we became good friends in Peradeniya and Kandy, because he had a house in Kandy, right? But all the way from Kandy. Oh, thank you. Any other questions you have or anything? Yeah. Yeah, that's right. Yeah. Don't feel shy. I'm not going to. Yeah.
Do you have a separate subject that maybe entitled design and technology or something, or are you expecting that to get the basics of what actually design means and develop the concepts of design writing and so on through their course, or do you do it all at the same as classroom?
Yeah, are you talking about the Singapore system?
No, the program.
No. Our program, the culminating thing is a capstone design project.
Yeah, but do you have a separate subject in first or second year that might be called design and technology or something like that?
We have some designs involved in other courses, correct. Like robotics, we have a course in mechatronics, for example. They might do a design there. I have seen the professor, I'm not a mechatronics guy, but they do a design and control sweeping the floors.
You have a separate course about design?
No, this is the separate course I mentioned, the last year.
No, yeah, before that.
No, before that, I teach machine design, one, and there's a machine design two.
Right.
Machine design is gear design, shaft design, bearing design, that kind of component design. Machine component, mechanical engineering component design. Of course, they do it in the third year. That design. Then there is another design also. Course. I think there are 2 design courses before the final design.
But you don't have
Thermal design. We have a thermal design.
more preliminary kind of fun and game side like 270. Do you have anything like 270?
We have ME 100, ME 100 and 101. They are really they are freshmen. They just came in first year and they have a design project.
And
Sure. That is compulsory. Yeah, absolutely. Yeah. They learn about design. Sometimes we put the senior 4th year guys with the first year to combine them a little bit to get the experience. Yeah, sure, absolutely. There are 2 of them, ME 100 and ME 101. Yeah. Introduction to design. Yeah, general design. You are right. Correct. Exactly right. Yeah, good point. Do you guys do it here too? You don't do it here.
That's correct. That's what we don't.
Yeah.
Now, yes, now you said that your capstone design 4th year.
Yeah.
So, during the year, what kind of time is it full year?
Full year, but they will do courses too.
Yeah.
But they can't do a whole lot of courses because they are doing the design, right? Yeah.
So that's the thing. That year in Sri Lanka,
Whole year.
Have that focus and that emphasis on doing design. Read all these definitions of Islam and design is the one thing that makes you an engineer.
That's exactly.
Yeah.
Exactly. Other courses are helping.
Yeah.
The education helps, but they are not the end of the thing.
I was hoping that Naveen was asking all these questions that it's our time that it's a cage with that.
Not as much as they should.
No, that's the thing.
Yeah.
You see, yes, and I wrote down saying, here, our time here, I was ready to admit, but we were told, did not make us decide at all. But we had the luxury of being thrown at lead when we came out and we looked at us for 2 years. So we managed to get, some kind of thing. That situation has changed. So that is why we need design more and more to be done with the university. When people do come out, that you are ready to go and start doing things. That we try hard to start doing that now outside the university, once we have come out. But it's a hard way. Some preparation for you to do a design with the university.
Right.
So I want to pick up one thing that you said. It's about these students going into the industry during the course and exchange A and B. And
Yeah.
I don't think is there any chance of that kind of thing being practiced here.
I think I encourage all my students to do that. In fact, we did that. As I said with DLO, I did one vacation though, summer employment with him. Then I went to Steel Corporation or Hardware Corporation.
Yes, they also voluntary. We did. I went.
You did.
But with you, is it a compulsion?
No. About 50% of our students do it. It's not compulsory. Some universities it is compulsory, mandatory. Yeah. Sorry, go ahead. I'm sorry. Yeah, I give it to her. Sure. Absolutely. Yeah.
I'm Pratt in Lnaka from Monash University. Of course, I got a chemical engineer. I'm a civil engineer. So
That's
it
fine.
all depends. When we do have in civil engineering,
Right.
our course is accredited by ISF, which is a member of the
Right.
board.
Right.
So the things that were showing are very familiar.
Right.
Outcomes and all that.
Yeah.
And we do design in the final year throughout the year.
Yeah.
But we start we are planning to start in 6 semester. So 7, 6, 7, 8. We can train.
Oh, very good. Yeah.
We call it the comprehensive design project.
Right.
Everything.
Yeah.
And my question is actually about research.
Yeah.
I didn't hear anything about the research project in your program. Can you just enlighten us?
Sure. Actually, I showed you 2 or 3 research projects which are master's level. But the undergraduates mostly do the design project. They can do research if they want to with another professor, but that is not very common. Research is done at the master's or the PhD level. And they do a project, they have to do coursework too, but classes, certain number of classes, and they do a project, fairly large project, you know. The masters might be 1 year coursework, 1 year next year project or thesis. Undergraduate program, not some do research. Very bright students do research, particularly if they are going to go do a master's and go into teaching or something. They will do a research project with some professor, and you can get credit for that. So in lieu of some of the technical electives, we have technical electives. They can choose solar energy or something. That may be a technical elective, or alternative energies. That may be taught only for a certain number of students. So if you have a large class, like we might have 100 students in the final year of mechanical engineering, only about 30 or 40 might be interested in that area. So they do that technical elective. Then somebody might do automotive engineering. That's a technical elective. They don't do. And some of those have design, again, in their class. And some of them have research also. And you can go with a professor and do research. And that might count as a technical elective and get credit. No. Only the project. Research, the design project is the most important thing. Design project, yeah. And to make it also, in the case of mechanical engineers. In the civil, I don't know whether you can make a large structure and so on, but you may be able to make a small one, I don't know, and test it. In the first year, they build bridges with sticks and things, matchsticks or whatever small things. Yeah, that's right. And they test it and so on. That is in the first year. They do that. I forgot to mention that. Yeah, sure, they do that. And they do that. That is introduction to design, concepts of design. Yeah. Okay. We do something similar. Yeah. Again, I'm not preaching that you adopt my system at all. No. You take whatever is good for you. Okay, because every country is different, right? You have to select the system that fits your country. Yeah.
I just want to tell you.
Yeah.
I remember you were you came back after your PhD during our second term.
Okay.
So
Somebody.
things have changed from that time to around 40
Very good.
years. I have been PhD for 40 years.
Yeah.
After graduating for 20 years.
Yeah.
So things have changed, and we are trying to get international
So,
experience for the students.
Yeah.
They are not as good as some of the universities in the world, but
Yeah.
we are trying.
Yeah, right.
Things have in fact
Change from that time. Yeah, good.
So we are
You
doing
keep
some
changing.
concepts.
Yeah, right. Very good. I'm glad to hear that. Yeah.
Glad to see you. Thank you. How many nothing can be replaced?
Oh, there is a lot too. Yeah. Sorry about that. Yeah, I talk more about mechanical.
I think we are the worst of. I agree with you. We have so much of learn from our mistakes. I would say, by and large, we coming out of the industry, related to decide economy. By and large, yes, but I don't think I said that at all. Because the opportunity you give in the faculty, for them to go that decide, and it can be difficult, but that is not there. We don't do enough in the university for them to be able to compete to go and start.
Yeah, right.
For that, so there are, after that, civil engineering, there are, for engineering, there are one other element also that is needed.
Yeah.
Is your appreciation of what mechanical engineering is.
Yeah, right.
That can come either through your lecturers who are well versed in industry or what
Yeah.
it's about,
Yeah.
or at least you are going out and working,
Right.
like that sort of sandwich kind of thing.
Yeah,
Now we have here in Sri Lanka, there
Yeah.
is this industrial training,
Right.
so-called industrial.
yeah.
Now, do you have a thing like that one in university?
Industrial training, is that done after the graduation or
No,
before?
no, during the course.
Oh, no,
Third
no.
year, recently now. Industrial training, 6 months.
Yeah,
or something.
yeah.
Two or 1 6 months. 1 6 months at Pratt Whitney. But there is nothing. So,
Yeah.
now that's a system that is there. I am very critical of the way how it is done.
Yeah.
Do you have a system like that one?
We have the co-op system, so
Yeah,
I
that
said
is a
that.
voluntary thing?
Yeah, voluntary thing. 50% of the students do that.
Yeah,
Other 50% will do vacation internships.
Yeah.
Again, it's more like voluntary, but most of them get a job during the vacation, summer vacation. We have a long summer vacation, like 3 months or something. That time they can work for a company, like I did with DLO or other steel corporation or hardware corporation. So that is there.
Is that a sort of mandatory requirement? You get your
No. You get 1.1 credit hour for doing that core program every semester, addition, 1 or 2, I can't remember. Maybe they get some for the other one too. They can do it as a credit to the course. Yeah. By the way, I have taken students from both Monterey and Peradeniya, probably about 20 students, to do master's, PhD. I gave them a scholarship, stipend, and tuition and everything. Every year I used to get one from Monterey too, not a lot, but Peradeniya. So they should apply, not only to Ohio University, but others. If I am at Ohio University, I will help them to get a scholarship because they are bright students. Only problem was the assistant lecturers from Peradeniya. So the dean was a friend of mine. So he said, JS, take this student. He's first class or second class. He's very good. Even a second class student is very good because very few first classes here. So I take them. They do the master's, PhD with me or someone else, and then they don't go back. So now the dean is telling that, send them back. I can't force them to go back. So they have a bond or whatever, but they can pay the bond, and so now they are not very keen in sending the assistant lecturers, to the US. But they have to get their degrees anyway. But you can do your own masters and PhD. I started the masters in manufacturing engineering in Monterey. Yeah, remember that about 15 years ago, 12 years ago. Yeah, with the ADB grant and all that, Asian Development Bank. I approved the list of equipment. They wouldn't approve it without my signature. So they have to. The head of department will say, I need this CNC system and all these things now. So they said some external guy has to come and approve this system that they are not wasting the money on. I don't know. Both Peradeniya and I started one in Peradeniya also. Brand new, and gave the first lecture in both campuses. Yeah.
Is there any product commercialization process?
A commercial?
Product commercialization process?
Oh, yeah. I forgot to mention. We have something called Innovation Center attached to the university. And if you have good ideas, we can commercialize that in that. And also, for the professors, they have started a new scheme that if you do a patent, 50% of the income of the patent will go to the professor. So there is a lot of people inventing new things now. Because in addition to their salary, they are getting a yearly income. Some of them, 3 professors in my department, when I was the chairman, came up with a new idea of cleaning few flue gases in coal power plants. So coal power plants is really bad for pollution, right? So they have these steel plates, huge steel plates, 60 foot or some long, hanging, and they are charged 10,000 volts or 15,000 volts. And the flue gas goes through that, and the dust gets attracted to those. And later, after a couple of hours or whatever time, they will send the flue gas to another station, and then take out the electricity and tap them, hammer them. So the dust will fall, and they suck the dust from the down. Okay. So these guys, 3 of them, very bright. One of them from Caltech, the other guy from Stanford. I hired them actually. And then other guy from University of Illinois Urbana, which is also top university. 3 of them came up with this idea of putting a fabric instead of the steel plate. You might like this. It's a carbon fiber, like a fabric. So what they do is they can electrically charge them because carbon is conducting, and also they can spray water in them if they want to, to increase that. And then after the electricity is turned off, they can do this rather than hitting it on the top. They can do like this, like that. Get the dust off and then suck it out. They won a huge patent. So they are going to get their royalty for about 17 years from the Southern Power in Florida. Southern Power, they control a lot of power stations. So they get a huge amount of money, probably a couple of million a year in addition to their salary from this company. Certain percentage of that, that company might be selling it to other people too, I don't know. So that kind of thing is there now in most of the universities in the US. To encourage, I think you should start that here too, I guess. They should get the royalty. It's part of the royalty. And the other 50% goes to the university. So more incentive for the professors to do projects which are worthwhile. Yeah. Sorry, anybody else? Yeah. So, taking time. Yeah.
What kind of mechanism do you have in getting design topics to the university?
Design topics. Some of them, some years we have the students choose them. Those helping the disabled, the students go and search and come up with and propose to the professor. I'm going to do this wheelchair or something, or propel something, or that competition with the STEAM that was given to them. So certain years we have done that. We have given a project idea to them. We want to have a thing run with external power, the heat or internal power or whatever, or electric motors or whatever, and that is given. And they can come up with any design, of course. They have a competition and all that at the end. Other years we have asked them to come up with their own project.
What about the industry involvement?
Industry involvement is always there, so they are working with industry for that project. They have to go to industry and look. Some of that core program helps a lot with that too. So if one of the students is working for a company, they will pick up a project from them. Okay.
If we have a problem, we are sickness problem.
Yeah.
By getting this,
Yeah. Also, Peradeniya told me I was going to set up a scholarship there with some money I had, in Sri Lanka. But they said I was going to set up a scholarship for somebody coming from Ratnapura, to engineering faculty, for 1 or 2 students. And they said more important is to give some money to do projects, some money every year, because they don't have money to buy the stuff if they want to design this stuff, design and make it, because they had to buy motors or something else or whatever, Yeah. So there is a need for that too, I think, right? I don't think we have enough funding, universities. See, I have been proposing, I know people are getting mad with me if I propose that, that every student should pay some kind of tuition, even a small amount, and subsidized by the government. I'm sure DLO will get mad with me for this. But if the student is poor, can't afford, government gives them 0 interest loan for the entire 4 years. Okay, entire 4 years, tuition, scholarship to the brightest students, and a loan for the other students, whoever asks for the loan. 0 interest, and then maybe small amount too. You can start with a small amount, and still the government will pay 80%, and you pay. Somebody has to pay for the professors and the equipment, right? Who's going to pay for that? And also, they will value the education more. They are not going to strike or do other JVP or whatever. I'm not against them or anything, but whatever bad things they might want to do to the property or to whatever. I don't think people appreciate when it is completely free. We are used to that. So I told this to a couple of politicians. They didn't like me at all, because they think they lose the elections if you do that. Yeah.
Even though charging
Yeah.
Even for stipend,
Yeah.
they expect them to come over and
Yeah.
there are also 27.
Yeah. Yeah.
So this is what we have to live with.
Yeah. No, but if you charge them and if they get a job only,
I
agree. Yeah. Okay. Yeah. You will also get a better salary. You will get equipment. You will get maintenance for your equipment. You can do design projects. You know, if you have money, extra money, right? Yeah, sure.
May I ask a question?
Yeah.
I heard that in Bhutan,
What?
Bhutan,
Yeah.
they have faced this,
Yeah. I don't think the switch is on. Yeah.
they have faced this problem
Yeah.
of poverty. And they have worked out a system where they advance money. I heard this from Bhutan, in Peradeniya University. And she said that their system is the cost is met by the government at a long-term loan. And in her case, it included coming and working in a foreign country, which was Sri Lanka, in Peradeniya.
Right.
When she got back, she had to work for 7 years or something.
Right.
To repay.
Yeah.
So this is in a small country, an individual system feasible.
Right. Right.
That is what.
Yeah. Yeah.
Maybe we are too big for that.
Yeah. I don't know. Yeah. No, but in the US, our university is state university. We call it a government university, Ohio University. They think it's private, it's not private. We get only about 40% or 35% from the government, 65% from the tuition.
So, I'd like to
Yeah.
ask you,
Yeah.
now when you got your D.Sc from London,
Yeah.
1991,
Yeah.
I remember we had Dr. Surya from Moscow, Dr. D.Sc from Moscow,
Right.
and somebody else. And we were just wondering, you might know about how you fit your personal academic agenda into your teaching. How does it work? Because London University is completely away from Ohio.
Right. How do you get a D.Sc?
How did you set up? Okay, D.Sc.
Yeah. D.Sc is given for research and publications. Yeah. So you have to, somebody has to propose to you generally. Another person who has a D.Sc generally. Yes. I was fortunate that my advisor from Imperial College was still living, and he proposed me for the D.Sc and also I think for the FCGI. You probably know that, City and Guilds. Yeah. I keep them because they don't charge any money. If SME also don't charge any money. If I make it, they reduce the charge, yearly charge, the annual subscription for the retired, but it's not zero. So I don't, I'm not paying when I'm retired. Yeah, and they charge a lot. How much is it? Kind of a couple of $100, I think, per year. I mean, I can pay it, but.
Have you thought of writing your story?
What? Writing?
Have you thought of writing your story?
Not yet. No. I'll take some advice from you. DLO, yeah. Give me your phone number, or I'll come and see you in Kandy. You still live in the same house? Up in the hill? I have been there many times. I have played cricket with his two sons. Yeah. They were little. Yeah. Retired professor. Yeah. Right. Yeah, I can do consulting or something if I want to a little bit. Yeah. I don't have a whole lot, but it is good to have patents. Yeah. In addition to the publications. Yeah. I'm trying to help Sri Lanka any way I can. So I might do some projects with Nalin and others here, Ranjit and all these people, you know. If they need any help, I have written to everybody, all the couple of top politicians, offering my services free of charge. No, nothing. I don't need any money. I'm willing to help. Tell me what you want me to do. I'll come and do it. I don't want to live here for 100%, but I might come for 2-3 months. I came for 2 months this time. Yeah. So I have said that, but I haven't gotten a reply yet. So I'm waiting for that.
Something I've always told them, say that there was a motivation for industrial recreation.
Yeah. Yeah.
They are not enough time.
Yeah.
Using that 4 years, we have been so many.
Yeah.
So, I would ask, before I ask that, how stressed are your students? How much pressure is on your students on your normal course in engineering, science?
Yeah.
So that you can't start to do anything for what percentage of time are they there in the classroom and that kind of thing?
Yeah. I don't know about the system now here. I mean,
No, I'm asking there.
Yeah. There we have quizzes and little exams almost every week. Every week there's a quiz at the end of the week for the material covered in that week. So, and midterms and all kinds of things. Not just the final exam. So the grading is done throughout the year, throughout the semester. So there is a continuous. They have to work continuously. That is different. So there is a little amount of pressure, but it's not the same pressure at the end of the semester or the year like we did. Part 1, Part 2, or now Part 3. But at the end of the year, only we have the exam, right? So we wait till the last minute, like a couple of weeks before the exam and scrap. So that's not the style there. We have to continuously do it. That means you have to absorb that material continuously. The students have to do that, right? Because they are doing quizzes and little exams and things. Yeah. So that is different.
I was like, looking also in this. I say, but in the 4th year, they have the design, they are complete. Who are asking me, people also say, after I use it, I can design this is something that is manufactured. So I get that one, must be complete enough so that somebody can take it and do it.
Right.
Never done, I guarantee, because I go for this company's certification, which is, I must say, I'm embarrassed. Look at some. So, but I think you have lost the point completely. You don't see that has to be. So that's what I'm trying to argue.
Right.
Kind of all these weekly these things and all, do the students get enough time? Or is it that they are ready to put that extra effort to do it?
Mm-hmm. Right.
That's a question.
Yeah. There is no very good answers, but it's a tough one actually. Yeah. But that
the 4th year
project.
Design,
Yeah.
What percentage of people complete it anyway?
They have to do it to graduate.
Yeah, that's compulsory.
That's compulsory. Yeah, absolutely. Yeah.
No, and again,
If you fail that, then you have to repeat. Repeat the
Yeah.
year. Yeah. But most of them don't fail. I mean, maybe a small percentage.
Civil
Yeah.
engineering, they have passed.
Yeah.
They have passed. No question. I think we are passing. Guarantee is passing. That's what we have made that change.
Yeah.
That is, if you impose that requirement, then I suppose somehow or other it will get done.
Yeah.
That is what it is.
Yeah. But in the final year with the design project, there is about 2 or 3 times they meet.
Yeah.
But every week they have to present what they are doing every
That's
week.
right, that's right.
So it's
Yeah.
continuously for the year, for the whole year. So the advisory board or the industry guy who is there and the professors, 2 or 3 professors will know how they are doing, so they can correct it if they are doing something wrong or advise them, so that they won't fail at the end. So there's a continuous tie up with the students.
It's been now another question. What is the ratio?
Yeah.
Teacher ratio.
Student ratio, I don't know, maybe about 15 or something. 20, 15 to 20. student to faculty staff ratio now. Probably about 15 or 20.
It depends on the university.
It depends on the university. Yeah.
Nowadays, it's not very bad.
Yeah. It's not too bad. Yeah.
I suppose what we have. Lay down the laws and you have to do it.
Yeah, right. You have to do it. Yeah. Actually, it is a lot of work, but you have to do it. The professors have to be involved. It's active learning, not just preaching, but you have to participate, get the students' participation. Yeah, in the whole thing, Yeah, they have to be talking. They have to present every week. I said that for the senior exam program. Every week they have to show the progress they have done. Thank you so much. Yeah, I think people are getting late or something. Yeah. Yeah. Yeah.
He mentions the building of the structures, engineering lab
Yeah.
in Peradeniya.
Right.
And in a very small way,
Yeah.
for the space,
Yeah.
and also that you can and with the number of rooms that have been playing with and they quite quick.
Yeah.
And on an earlier occasion, I recall Professor Peradeniya said,
Yeah.
at least in the contract,
I'll delete this, no?
there was some message that they were educated. Interdisciplinary kind of mix, and it's not easy because the focus is on the exams.
Right.
And
Right.
like that is better.
Anyone else? Thank you.
Final year, sir.
What?
Capstone project.
Yeah.
That's about 20%.
Yeah. That's what
They have to pass that in one ticket.
That's very true. Very because the continuous interaction and being with whoever is participating. It could be industry, it could be a hospital, sometimes health hospital. Maybe I'll be somewhere in the hospital or doctor comes to the class or
So is the project marked out not 100% or ABC?
yeah, usually ABC we give A minus, B plus, B minus like that.
So the GPA, they can expect how that.
Yeah, A is 4, B is 3 and A is, C is 2. A minus is 3.7, B plus is 3.3 and so on.
So I hope you don't have more questions. So good evening, everybody. I'm Monash University representing Mechanical Engineering Section Committee. So first and foremost, I would like to express my sincere gratitude to our guest lecturer, Dr. Jay Sarath Gunasekera, for accepting our invitation and delivering a wonderful lecture on engineering education as global perspective. Going ahead with that, actually, Mechanical Engineering Section Committee, we are doing a lot of work this year based on 3 themes: transportation, innovation, and energy. So I would like to invite all of you to come and actively participate with that. And you may follow us on Twitter as well as ISL website. So while giving that message, I would like to thank our chairman, Engineer Arjun Manamperi, for leading us, for guiding us to do such work. And special thanks goes to Engineer Parakram Jayasingh for finding our guest lecture, coordinating with him, and arrange this wonderful session. And since he discussed about the design, actually he is doing wonderful job, because as mechanical engineers, we didn't get any chance when we pass out from the university to do a better design. So they are conducting a wonderful session. It's called mechanical engineering design, targeting the charter process. But still, it's a very valuable course. And I would like to say, I'm also a product from University of Peradeniya, especially from production engineering department. So it's very glad to be here in front of our co-founder of department. And I must thank our friends who are doing wonderful work here to arrange this lecture, Mr. Asita, Engineer Asita and Engineer Damit. And we have two messages to deliver you. One is, we are doing a lot of public lectures like this, so we need more publicity. Actually, we can see a lot of empty seats. We need to fill it. So we kindly request you to publish this flyer. Whenever you see a flyer for such kind of lecture, please forward to your friend and try to accompany someone. So it will be a great help to deliver this message to our engineering community as well as public. So the other message is, we are having 3 more lectures. On 17th March, Dr. Engineer Gamya Kulatunga will deliver the art of listening, under the topic of art of listening. And 24th March, Venerable Walasmulle Abe Tero will deliver a lecture, Think Outside the Box. And again, first week of April, we'll have a panel discussion on engineering entrepreneur with good resource persons. So you will be getting that flyer very soon. So please publish it and try to accompany a lot of engineers as well as public to this place. So that will help us to deliver our message to the society. So I must thank our friends in ISL, Kalana and Chamara, who did a great job by providing technical support, and Ms. Ramani and Ms. Sanduni for all other arrangements. Last but not least, I must thank you all. Without your participation, this event would not be success. So as a token of appreciation, I would like to invite Engineer Parakumi Jayasinghe to come forward and hand over the memento to our guest lecturer, Dr. Jay Sarath Gunasekera.